All right, good morning, good afternoon, good evening, wherever you're at. Hope you're doing great. We're going to be talking about coordinate proofs here in 1 second. But just want to continue to review what we talked about yesterday as far as finding these points within the coordinate plane. And so, if you can walk through number 1 by yourself and double check it here in a second, that would be ideal. But if you can't, just take a look up here and walk through this with me, because this is really important. Finding these points out here, it'll make your life a lot easier on the next test. So looking here, the first thing I would do when given something like this is to go ahead and draw a squiggly line through your rhombus like I did there. Man, that's terrible. I want to show the diagonals. Now the reason why I did that is because, again, remember, the diagonals of a rhombus are perpendicular and they bisect each other. So I'm going to go ahead and put down that those two lengths are the same and that those two lengths are the same, okay? Now from there, remember what we said yesterday, each of the given points tells us something about the information that's needed to solve the rest of the figure's ordered pairs. So if I look here, this point tells me how far over and how far down we had to travel to get to that point. And that distance there is going to be a length of negative a, comma, negative b. Okay, if you notice here, negative a is the x value, that's the left and right, the x value, and negative b is the y value, that's up and down. Okay, now this length over here is also negative a because they're equal, and so r, its ordered pair, is going to be negative 2a, comma 0. Okay, so hopefully you got that right if you had a chance to do it on your own. And this length here is equal but in the opposite direction. So if this is negative b, then this length is positive b. Put that out there, and we're going to go over negative a, up b, and that's what my ordered pair is going to be, negative a, positive b, okay? So again, we're just continuing to review that and making sure that we have those parts down there. Now from there, I want to go down and take a look at this next problem here, all right? Now here's what's going on in this next problem. We are going to prove that the mid-segment of a trapezoid, okay, produces a segment that is parallel to both bases. That's what it says right here, that this mid-segment is parallel to both bases here, and that the length of the mid-segment is half the sum of both bases, or basically the average of both bases. And so what I want to do first is I want to make sure that I understand that this is a mid-segment. So remember, a mid-segment is a segment that joins the midpoints of two sides of a figure. So I'm going to go ahead and label that just like that. And over the next couple of minutes, we are going to prove those characteristics have to be true within that trapezoid. Now, in order to make that accusation, okay, that statement, you need to show all of your work as you do this. And I know it's going to be a lot of work to do this, okay? But you're basically writing a story from beginning to end, and we don't want to leave any detail out of that story. If you do, the reader might not understand how you came up with the conclusions that you come up with, okay? So as we walk through this, let's start with finding the ordered pairs of points m and n. If you think through the 3 formulas that we talked about the other day, the midpoint, the slope, and the distance formulas, which formula would you want to use in order to figure out the ordered pairs for m and n? Well, I hope you're thinking to yourself, I'd want to use the midpoint formula. So I'm going to go ahead right here, and I'm going to write that down. Okay, it's the average of the x's and the average of the y's. Okay. Now you guys did this the other day. You're probably able to go ahead and do that a lot faster than what I can. And so I'll go ahead and start in for point M. Whoa, I don't know why that happened there. Point M, okay. And in order to do that, let's go ahead and put down here the ordered pair for T would be 0, 0. And so I'll go ahead and write this down, 2b plus 0 over 2. Okay, again, that's the x values here and here. And then 2c plus 0 over 2. Okay? And if I simplify that, 2b over 2 becomes just b. So I'll write this over here next to point M. And 2c over 2 becomes just C. So it's actually B comma C for point M. Now for point N, okay, to find its midpoint, I'll go ahead and do something like this. Let's say 2D plus 2A over 2, comma, 2C plus 0 over 2. If we do that, we get the ordered pair of, now we're dividing both of these terms by 2 here, so you end up with D plus A, comma, C. Okay, dividing that term by 2, you get just C. Now, as I add this to my diagram over here, I'm going to change something real quickly. In algebra, usually we order things in alphabetical order. So to make this nice and neat, I'm going to put A plus D, comma C. Okay? That just cleans it up a little bit there. Now, the next thing I'm going to do is I'm going to erase the work that I've done because I'm going to run out of space on my page if I don't, so that we can see everything that's taking place. Now, you should not erase anything. The work that you're doing right now is actually showing me how you know what you know to be true. Okay? Now, the next thing that we need to consider is this. How are we going to prove that MN is parallel to those two side lengths right there? Well, I hope you're thinking to yourself, we're going to use the slope formula, which here's the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Now, if I plug in those values here, the slope of MN, okay, let's think about this here. It's usually good practice to start with the point that's furthest from the origin. So using the y value there at C, I'm going to do C minus C over, again, that's the C here minus the C here. And I'm going to use the x value here minus the x value there. So it should be A plus D minus B. Okay? Well, if we take C minus C, that actually equals 0. Okay? And then if we think about this, 0 over any number is just 0 itself. Okay? So the slope of MN has a slope of 0. Now I'm going to continue on with TP and RA. So TP has a slope, okay, of, so let's go ahead and do this, 0 minus 0. Okay, those are the y values. Over, I'm going to say 2a minus 0. Okay? And again, I hope you know where I'm getting the x values and the y values there from T and P. If not, you might want to ask someone what I'm specifically doing there. 0 minus 0 is obviously 0. 2a minus 0 is 2a. And it simplifies down to just a slope of 0. Okay, so right now I've proved that those two lines are parallel to each other because, again, they have the same slope. For RA, if I can go ahead and show this here, I'm going to start with A being the furthest point from T, or the origin. And so we end up with 2C minus 2C, okay, the y values there, over 2D minus 2B, okay? Now again, the difference here is 0 over 2D minus 2B, and thank goodness my slope is still going to be 0. So at this point in time, if I had a coordinate proof, I would probably go ahead and say, therefore, I know that MN is parallel to TP, which is parallel to RA. Okay? I've proved all three of these segments are parallel. And I might even come over to my diagram and put that in there just so I can say, hey, I already know that this is true. Okay? Now we've got one last thing to fill out here to finish up this proof. Okay? Like I said, there's a lot of work involved with these coordinate proofs. And that's this. To prove this formula right here, this equation, I need to know what the length of MN, the length of TP, and the length of RA are going to be. Now, in order to get those lengths, I'm going to use the distance formula. Okay? So here's your distance formula. Okay? And we're going to go ahead and plug in the values and simplify everything. So let's actually start with, we'll work from top to bottom. We'll do RA, the slope of RA. Not the slope, I'm sorry, the distance of RA. And again, I would start with the point furthest from the origin. If you don't, especially with the distance formula, it can cause some difficulties algebraically. So if we do that, the x value of A is 2D. The x value of R is 2B. Okay. The x value, or the y value of A is 2C. And the y value of R is also 2C. Okay. Now at this point I'm probably going to go ahead and say, hey, I know what this is. That's 0. That's gone. It has no influence on what I'm going to do from here on out. Okay. And if I continue working down here, what we have here, 2D minus 2B squared. Now, you know, yesterday I talked about this, and I'll get rid of this in a moment if this confuses you, but if we have this, okay, I said the biggest mistake that students make at this point in time, when there's a plus sign right here, is to go ahead and say that the square and square root cancels out to be just 7 plus 5 to be 12. Let me show you why it's not 12. We know that 7 squared is 49, and 5 squared is 25. If I add those two together, I get the square root of 74, which is approximately 8.6-ish. Okay? Definitely not 12. So when there's a plus sign between two terms that are squared, we can't simplify that any further. Okay? But let's consider what we're doing right here. We don't have a plus sign, we have a minus sign, but plus minus, it's really irrelevant. The question is, can I cancel out the square and square root? Well, let's do this. If I were to plug some numbers in for B and D, here's what we would have. Let's say that D is 3, and let's say that B is 4. Oh, I can't do that. Let's say this is 5. Okay? I can't have a negative underneath the radical, and you'll learn about that next year. Okay? And so from here, if I can cancel out the square and square root, this would be 10 minus 8 to give me an answer of 2. Okay. Well, here's what we're going to do. To work this all the way out, I'm going to go ahead and simplify what's underneath the parentheses right now. And so we end up with a 2. And then 2 squared is 4. And what's the square root of 4? Well, that's 2. So what we've just proven, sorry about that, my pen wasn't working, is that we can cancel them out when it's just one term that's being squared. So in this case, those guys are gone, and the length of RA is going to be 2D minus 2B. Okay? All right, now, taking a look at the rest of this, all right, looking at, let's do MN next. If I go ahead and do MN, plugging in this into the distance formula, here's what we have. I'm going to start with N, which is the x value is A plus D. And I'm going to subtract M's x value, which is B. And then N's y value is C. And then M's y value is also C. And so C is gone. And now I can go ahead and simplify this. Here's what we have. A plus D minus B. Oh, I'm sorry, that should be a D. D minus B squared. Okay, and again, it's just one term. This whole parentheses squared. So those guys are going to cancel out. And the length of MN is actually going to be A plus D minus B. Okay? Whew, lots of algebra there. Lots and lots of algebra. All right, now, last one, TP. Let's do that one right there. TP, square root. I'm going to start with P. 2A minus 0 squared, and then 0 minus 0 squared. Okay? Again, this is gone, so we end up with this. And the square and the square will cancel each other out, so you're left with 2A TP. Okay, so there's the length of TP. Here's the length of RA. And here's the length of MN. Okay? Now, from there, we still need to prove this formula right here. Okay? And so, if I have that, I'm going to go ahead and write down the formula one more time just to make sure we've got that. And I'm going to plug in what we found and see if we maintain equality on both sides. So, if I plug in Mn, which is A plus D minus B, will that equal 1/2 TP, which is 2A, plus RA, which is 2D minus 2B? Okay? Well, hopefully we've done enough algebra this year that you can look at this and say, hey, I want to get rid of those parentheses. If I do that, A plus D minus B is equal to A plus D minus B. Oh, hallelujah. They're equal, which means that equation holds true. Okay? So, how does this all play out? Well, on your test, I'll give you some information and I'll ask you to figure out the missing parts. For example, I may give you this is 10 and this is 14. And the question is, what will that be? Well, I hope you'll remember this formula here and plug the values in. So if I do that, Mn is unknown, TP is 14, and RA is 10. So 24 divided by 2, that's 12. I'm going to know that Mn is a length of 12. Okay? So, yeah, length of 12. Okay? Another example I could give you, if I was to give you something like this, 9, this length is 9, and this length is 16. Okay, the question would be, what's RA? Well, again, I can throw that into my formula here, and we have Mn is 9, TP is 16, and I can figure out what RA is by getting rid of the parentheses. Equals 8 plus half RA, and then subtracting 8 from both sides, and then dividing by half. How many halves are there in 1? There are 2. So my answer here would be 2. Now, some of you may be starting to recognize a pattern up there, okay? And here's what I hope you see. Since this segment right here is the average of the two bases right here and here, that means the distance here has to be equal to the distance here, okay? And so if we go back to the previous problem, does that hold true? Well, the distance here was equal to the distance there. And so, yeah, if you can think of that may help you. So if I were to go ahead and do something like this, let's say 12, 25, the question is, can you find TP? Now, you can plug it into your formula, but you can use the shortcut method that I just showed you, which, again, would be the difference here, 13, the difference here, also 13. So there's my answer for the length of TP, okay? So, I will tell you this, I probably could throw a curveball at you too, and go ahead and do something like this. X plus 4, 2x, and 18. I'm just making those up, but obviously you want to plug them back into your formula and solve for x from there. So, with that being said, I think at the bottom of your paper there, you've got the two parts of the theorem that we just covered today. And the first part's the mid-segment. So you want to write that down. The mid-segment of a trapezoid is parallel to the two bases. Okay, again, the mid-segment of a trapezoid is parallel to the two bases. Number 2, the length of the mid-segment of a trapezoid is half the sum of the length of the bases. Okay? So, I hope that was all clear and understandable. If you have questions, come and see me tomorrow, but I appreciate your attention, and I hope you have a great day and great night. Good night.